Hi there, welcome back. We are excited to deliver the last session of Azure Week to you guys. We started out the day today talking about all things mobile. So we started out with notification hubs, which was a really easy specialized push service you could hook into any existing app backend. So that was something you could pick up and get running with right away, maybe with some applications you already have, or obviously with applications you're building. Then we moved on to focusing on mobile services and what Azure offers in conjunction with Notification Hub Service Bus in a variety of scenarios, from consumer all the way to employee facing. Covered some good stuff there, and we were glad to have Kirill. But now I'm back, and I'm Miranda Luna. I'm a product manager on Windows Azure Mobile, and Abhishek is going to be joining me today.
Hi.
And we are going to be talking about some pretty popular buzzwords, M2M and IoT. You've probably heard it a couple times, two, three times. So we will definitely be covering what exactly we mean in this session by M2M and IoT, because I think they've been used in pretty much every way possible by every person that exists. And then we'll go into a scenario overview. We'll focus in on kind of a connected car scenario today. Talk about some of the technology challenges. Then we'll go over patterns of communication and a messaging solution. We also have a Raspberry Pi here today that you might be excited to see what we're going to do with it. It's going to be awesome, so definitely stay tuned and let us know if you have questions as we get going. Let's kick it off. Another reminder for the Microsoft Virtual Academy, definitely join the community. Over 1 million strong, people tackling the same problems you are. Don't just learn from us, learn from each other. And there's definitely some get started codes available here if you wanted to get some extra points. So in terms of an overview, what are we covering in this? This whole day today during Azure Week was kind of focused around connected devices. We called it mobile apps to IoT, everything you need to know in connected devices. So what do we mean by that? We mean, what you're connecting with in terms of your interactions with the users, smartphones, tablets, web. And we talked a lot about Azure Mobile Services and some about notification hubs. We didn't cover websites, but they did earlier in the week, and it's a pretty familiar concept to most folks. But basically, those are the channels through which you interact with the users. In terms of how you interact with the devices from the cloud, you have to think about it in kind of a different model, right? It's not just kind of landing your content on the device, it's how are you enabling that communication. And that's where Service Bus comes in. So Abhishek and I are going to talk to you a little bit about queues and topics and relay, probably more focused on queues and topics today.
That's right.
And hopefully we'll do a quick level set with everybody, not just on buzzwords, but on kind of what actually does queues and topics mean in relay or in Service Bus. And then we'll get going with some fun demos.
Awesome.
Sound good?
Yes.
All right. So buzzwords. I know they're your favorite thing.
I know.
Yeah.
I want to make sure that I'm fully buzzword compliant at all times. So with
Buzzword police is here.
With M2M and IoT, just in terms of definitions, right? M2M generally refers to devices talking to devices, so machine to machine.
Absolutely.
Or most of the times, it's actually systems talking to systems. So it's patterns of communication which are generally not involving human interaction in them. So that's mostly what M2M is. IoT, Internet of Things, started as a vision that we could automatically capture data from the physical world and use it to like the internet is used to exchange information, achieve some cool scenarios in there. What it has started referring to is sort of the explosion of the kinds of devices and the number of devices, which are now more and more connected. But in terms of just buzz out there, I mean, you've heard Internet of Everything, Internet of Things and stuff. I just want to call out, it actually started with a very, very simple scenario of being able to bring data from the physical world into the cloud.
Interesting, yeah. I think that's definitely something that's gone a little out of control, right? It's like, I can change the light on that. Like, it is an Internet of Things scenario, but it's a little different than what the vision was originally.
Correct.
So just to level set, what we're going to be talking about more today is, how you can enable we're going to talk about communication patterns in devices, and especially using Service Bus for that messaging, and talk a little to what sort of scenarios that enables. Some of them are going to be physical devices. We have a Raspberry Pi here. Then others are more just to illustrate kind of what that means in terms of the systems. So we talked to you a little bit about what things encompass, which, as you can see, is a wide range. And if you ask 100 people, I think you'll get 105 different answers. 5 people or 100 are typically pretty created. But the key thing to remember about things on the internet is that there's 3 big areas. They're directly connected, either a sensor. We talk about power grids and traffic monitoring here, but think about even in oil fields or mines, where it's kind of very important to not only the employees but to the business, and for safety reasons, basically running the gambit. Then connected devices, smartphone, car. We talk a lot about wearables, but a lot of people like to think of it as even Nest or a Fitbit or a Nike Fuel Band, and then any sort of field gateway that kind of just acts as that front entryway for much more connected devices behind it. Do you want to talk a little about the building blocks?
Yeah, absolutely. So now that we have a picture of what devices are and sort of how do they connect, the Internet of Things to me is essentially building blocks. You need the aspect of collecting data, which was sort of the original vision, just be able to capture that data. And this is where you hear discussions about big data and technologies, in terms of managing both the volume, the velocity, as well as the variety of that data. And once you have that, you have to connect and communicate that. So whether it's sending it up to the cloud or whether it is processing it locally, there's that processing aspect. And then the last piece, which I think really delivers on the vision, is that interaction. Is how do you reach back and touch the device, or have update a sensor, or maybe stop a drill in an oil field or something like that, right?
Yep.
It's essentially the idea of a smart cloud. There's smart processes and machine learning and stuff in the cloud which can make decisions which a device or a sensor cannot. And then there are controllers and sensors which are either providing the data or the cloud is interacting with and being able to modify the state of
Right. So probably a good time for a level set on service bus.
Yep.
A lot of the audience is probably pretty familiar, but it's still interesting to see kind of how difficult it is to grasp in some scenarios and which is better for which. I think that everybody kind of grasps the queues are better for one-to-one and follow a first in, first out, very simple messaging framework. And kind of topics and subscriptions give you the ability to go one-to-many. But in terms of matching subscriptions and topics and using that efficiently in M2M scenarios, is there anything you found people are kind of any sort of errors that are pretty common or mistakes that are easy to make?
Yeah, absolutely. I think the way folks generally, there might be some common traps which people fall into is maybe thinking of scenarios like a queue per device, right? Each device has its own queue kind of thing, which is a pattern. But if you think about it, essentially you might want a queue for a message type, right? So if you're sending traffic information on a regular basis, you might want several traffic sensors coming into a queue.
Yep.
Because a queue is generally a fan-in pattern where the idea is you want one pipe in which to process from, and then you have lots of sensors sending data in there. And with the service bus, we provide you not only this one-in, one-out pattern, but topics is the next sort of step to that, where you'll imagine when you have streams coming in, you'll want to split these streams of data. And these could be complete splits, like the same stream being fed into an analytics system, into an audit system, into a logging system, into some real-time processing. Or you might have filtered streams, where you might be sending only part of the stream to different processors. So that's when topics come in. And again, sometimes folks use them interchangeably. A topic with a single subscription is like a queue.
Yeah.
It's kind of thing. But essentially, the beautiful part about a topic is that as time goes on and you need more and more splits of that stream, you can keep adding more subscriptions there. So
Yeah, I don't know about you, but I've typically found that kind of that common trap you described, where you're going one queue per device, is coming out of that world where everyone who was watching earlier, Kirill and I were talking a little bit about how to kind of do that push from device, raw push notifications, and have it the device pull your web service.
Right.
And I think that it's coming from that world where people think about devices as associated with a person instead of as a function of a wider network of devices.
Very good point.
So that's how it helped me think about it. Maybe it helps somebody else. Yeah. So there are 4 basic patterns of communication that you're going to see in M2M type scenarios. Telemetry, which is basically an information flow. Inquiries, which is that kind of polling scenario we were talking about. Using service bus, pub sub, as we talked about with Kiro earlier, if you were in the employee-facing application session, there's a way that you can have your device using PubSub make a query back up to your web service that's already set up with PubSub messaging, and then have that activation happen. In terms of commands, that's what we're going to show you a little bit about today, is kind of how can you actually initiate an action in the receiver from the sender. So it's not just pushing information, it's not just pulling information, it's actually taking an action. And then notifications, which you should be very familiar with at this point in the day. We've been definitely extolling the virtue of notifications, and not just in terms of, a push notification as a tile or a toast, but notifications in terms of, hey, I'm going to send a notification to wake up the client-side application and have it take some sort of action. So these can work together, but those are basically the 4 models we're going to be talking about today. So now that we've gotten through kind of the level setting, in Module 2, we're going to cover a really good scenario and some technologies challenges associated with it. We're going to look at a connected car, and then we're going to do some demos. So, we just pulled from a variety of popular scenarios, as we talked about earlier. You ask about IoT and M2M, you're going to get a lot of different answers. People talk about smart cities and factories and homes. But since cars are really something we all interact with every day, and we've seen the incredible evolution of technology within cars, we thought that'd be a good kind of scenario in which to highlight some of these features. So, Abhishek, do you want to go ahead?
Absolutely. So I picked up a scenario which sort of sounds interesting to me with, especially if you have kids who are, starting to drive and stuff. Let's say you have a goal, you want an app, a phone app, you want to deliver a phone app, which will notify you every time your car is speeding. So just think about all the different pieces in there.
I'm sure an insurance company wouldn't mind that either.
Absolutely, absolutely. So now if you think about all the different pieces that you would need to build to do that, you have your cars and your users. Your users are going to be interacting with tablets and PCs and websites, and they want their notification. And then your cars need to be connected up and be able to transmit that information. So the first piece where the cloud comes in is you can use Service Bus as a ingress and sort of command and control channel, telemetry and command and control channel for connecting the car. And the idea about using topics and queues is that you get a lot of different communication patterns, which we'll see in detail, which really facilitate that communication. The next step would be of, how do you interact with your users? And, since this morning, you've seen some awesome sessions on mobile services. You already know how to build good, easy apps, which can, notify your user using notifications, or just, present data, capture data from them, and store state. And then finally, the magic of the cloud is that with all that data coming in, that raw data, you're going to be able to process it at speed, at volume, in a scalable way, and be able to utilize external services in the cloud. Like, for example, you can use Bing APIs to go figure out the speed limit on a particular road. Mm-hmm. So you can now track your GPS coordinates, find out what the speed of that particular location is, and then be able to use that information to determine whether a car is speeding or not speeding. So that's why the cloud really sort of brings all of this together. Mm-hmm. So the first challenge, which I want to start with, is just the communication and remote access challenge. Well, how are we going to go talk to the device? The next we'll look at is the bidirectional exchange. That is, not only does the car have to send that information up, but maybe you have to send information back down to the car, and how do you solve those kinds of scenarios? And then in the cloud itself, you of course have the storing and processing of the data. Now, you've already gone through cloud services and infrastructure as a service and different processing platforms. Mm-hmm. So Azure is a very rich data processing platform. I'm not going to go into much detail of that, but that's what you would use to tie up these scenarios together. And then one thing I really want to touch on today is the identity and security aspect, because that's something which really becomes a challenge, in terms of users' data and privacy, and those are big concerns these days. And how, some of the approaches when we are solving the connectivity and remote access problem, we think about those scenarios.
And then, of course, scale, which is part of any cloud conversation.
Yes, absolutely, absolutely. So the first thing I want to set a premise on in terms of Service Bus is Service bus is a polyglot messaging service, which means it speaks many protocols, speaks many languages. And the way to think about that is protocols not only give you reach. So example, you can see with SBMP and HTTP, we have high performance scenarios as well as high reach scenarios. And now with the new standard AMQP protocol, we have both high performance as well as high reach. So you've really got the best of both worlds coming together with AMQP. And when I talk about performance, think about some challenges where, let's say you put out this app, and now you have all these cars which are sending data and things like that, and receiving back information. Imagine how that scales up over time. Like if every car has to poll again and again and say, hey, is there an update for me or something like that, that can really hurt your performance on your servers. So AMQP, being a bi-directional connected protocol, is not only very efficient from an uplink perspective of being able to send a lot of data up, but it is also very efficient in listening on a silent connection to pull data down.
That's really important, especially in this scenario where you would be not only pushing that speed information up, but you're also pulling down information from the Bing APIs that you're hosting in a web service, and then you're also maybe dropping a message to your son or daughter that says, slow it down, chief.
Absolutely, absolutely. So that's why it's really important to see the value of that. And with AMQP, if folks are not aware, there's a bunch of literature out there. I just want to call out, it's an OASIS standard. There are a bunch of companies behind this. Microsoft is one of the partners. We've got technology vendors. We've got JP Morgan and stuff. So there's a lot of good momentum behind this protocol. And it's already an OASIS standard and working towards ISO standardization. So what does it mean to you? To the developer, it really means a lot of choice. It means a choice that you can use the service bus topics and queues as a broker and use it on any platform and any language of your choosing. There are open source libraries. Here, as I call out the Apache's Cupid project, you can see all the different options you have in terms of Python, C, PHP. All of those libraries and choices are available, and you can run them on Linux or other device kind of platforms in there. And then if you're using Windows, then you still have a bunch of options. Azure has SDKs in Ruby and Node and all of those, and we have all of that available, which can use our HTTPS protocol. So you can really see a lot of rich reach in terms of service bus being a multi-protocol broker.
Definitely. So I think that everybody wants us to get to the pie.
No, absolutely. So let me show you, what's going on here. Essentially, I've got a Raspberry Pi device. As you folks are aware, these are, you can just buy it off Amazon, get it on the internet. It's a very, very neat form factor. You can imagine you can use this for a lot of scenarios. And it's very extensible in that we're talking about cars today. So you have a very, very simple adapter, ODB adapter, which plugs right into this. And that connects to your car. So right there you have a computing platform locally as a device which solves that problem for you. Now what do you do with it? Once you've got the adapter connected and you're collecting all this data locally, well, how are you going to get it to the cloud? That's where service bus queues come in. So I want to show you a quick demo of... let me actually start with the Azure portal. So in case you don't have a queue created, I'm going to create one really quickly. I'm going to go to App Services, Service Bus, Queue, and do a quick create. And here I'm going to just choose my namespace, the Abilal demo namespace, and I'm going to call this IoT. And I'm going to say create a new queue. We need to stick with our buzzwords.
Yeah, right? I know. Please, please don't depart. We've come so far.
So what I've done here is created a simple queue right here, and I can see it's activated now. And I can go look at messages on it and what's going on. I can configure the queue where I can add some information here in terms of what's the lock duration and the queue state and things like that.
And I'm assuming this is all available through the CLI tools as well.
Absolutely, absolutely. Great. So command line tools are available. The other place where this is really, really powerful and useful is if you're using Visual Studio. So here I've got the Azure SDK installed, And all I've done is expanded the service bus node, and you can see my namespace shows up here already. Now, if I go expand on that, I should be able to see, I just created the queue, so let me go refresh this node, and this reaches out. It should connect to my namespace, get all the latest entities and information, and there you are.
Yep.
So I've got my queue showing up. Now, it's a very easy debugging scenario. I'll just focus here on the properties pane, because I can now very easily see some useful information about my queue. Right now it says active message count is 0, so I don't have any messages in there. It shows you when the queue was created, as well as all the different properties which you might need for debugging. Now let's jump into the Pi. Here I've got the latest, actually it's not the latest, Cupid Proton just released 0.6.
Did they?
Yeah,
okay.
I have an older version here, 0.4 right now, so I need to update to the latest builds. But essentially what I can do here now is put in the credentials which I need, and this is where the auth factor really comes in, right? And we'll talk about how do you secure on a per device kind of basis. Put in my credentials and just send a message in AMQP.
So this auth is provided by the platform provider, or this is not something you built in?
So this particular authentication is, I'm using AMQP based authentication to go connect to Service Bus in the cloud. So Service Bus supports a couple of different types of authentication. We have the shared access signature model, as well as we have integration with access control service, which is the identity based model which we have in the cloud. So both of those models are supported.
Great.
So switching back here, you can see I just did a hello message, send, and let me quickly check, did that message ever show up? So if I come back to my queue and I do a refresh,
there it is.
I will see that the active message count is 1. And as simple as that, you can see now this device, which was a headless just device in your car, is now connected up, and it can exchange information in there. It can send up telemetry data in there. And now, from a debugging perspective, let me just do receive the message. So I get this message out. And to show you that bidirectional aspect, right, where the idea is you not only you're able to sort of send messages up from the device to the cloud, but you want to be able to work on the other direction too. I'm going to do, so here you can see right now the message count is 0. Now I'm going to do send a test message. So all this does is sends a test message to this queue, and it will, once the queue refreshes, you can see now from my cloud or from another client, I have initiated a message transfer. And if I go back now to the device, from this device itself, I can now call a receive.
Perfect.
And this is the other direction of the story, where I hit the same queue, with the same credentials, and do a receive object, and you can see the test message, which I just sent was available in there.
Perfect.
So that essentially shows you end to end of how easy it is to get started with Service Bus, create a namespace and a queue in the cloud on the portal, use rich Visual Studio tooling to debug your application, develop your application, and then take a device like this Raspberry Pi, which can be used for local computation, can be used for local data collection, and then be able to connect it up to the cloud, not only from a telemetry perspective of where the data is just going up, but from command and control.
Which is really important, and that's kind of actually giving some weight behind those buzzwords and actually making it something a little bit more tangible. So I enjoyed that. I think around this time, a bunch of people who are watching are probably thinking, but what about VPN? Why should we be going in any direction? VPN's been around for a long time. Definitely a lot of IT pro experience in that. It might be some, regulations that developers are asking, like, what does this mean in terms of what I can do in a connected devices world? How do you kind of approach that?
No, absolutely. So the way to think about that, Miranda, is that VPN comes with a lot of challenges, especially when you think about these kinds of devices. There is definitely device complexity challenge, right? Like, is your device really capable of being able to, support VPN, complex software and stuff? And then the physical security of it. How do you, when all your devices and everything are maybe sitting inside your factory, at that point you can have some physical boundary. But look at the example we have taken.
Yeah.
This device which you have created is going to be running around, all over the city or the country or the world, right? Depending on, your reach of your application. So how do you secure that within the network? And then the other challenge which VPN creates is that it doesn't protect folks who are all inside the VPN. So now one device, which could be compromised because it's sitting outside of your physical control, has enough power to go access all the other devices in there, which are now sitting within your particular boundary, and be able to, snoop into their data or be able to access their kind of data. So that really is a big challenge. And these are sort of the things why I feel that VPN is not a very good solution.
Gotcha. And in terms of the cost associated with scaling it, I mean, I feel like that's where a lot of it comes in, and that's also kind of where developers can talk to their IT pro counterparts and say, listen, how compute and memory intensive is this solution? Given those complexities, is that really the right way we want to be going?
Correct. I absolutely agree. So from a service bus perspective, we, like I said, offer you shared access signatures as well as, identity-based auth. And here the model is really a tokens and a claims-based model.
Right.
So the idea is that either you give it a key per device or you give it a token per device, and then that's the only permission and claims you have. It's all about this complexity of security living in the cloud, living at your cloud service endpoint, not on the device endpoint. Yeah. And that shift, that inversion, where VPN requires your local device to be secure versus the service-assisted connectivity model where your service is secure and you're able to apply your best kind of DDoS protection, and you're able to revoke claims, and you're able to blacklist devices and things like that. Yeah. Those scenarios are really best served in terms of the cloud.
Yeah. So what if let's think about scenarios where there's a device with limited bandwidth or intermittent connections. I mean, offline is obviously a huge problem and a complex issue, not just with mobile apps, but with devices.
Right.
What's kind of the approach we typically take in service bus?
I'm so glad you brought it up, because this is where the brokered messaging model really comes into play. Because think about the telemetry scenario first, right? So locally on your SD card, you're only able to store some amount of information, right? And then because you go through a tunnel and then you get connectivity again, you can now batch that data up and very efficiently and quickly send it up to the cloud. On the reverse side, it's even more important. Like you saw with notifications also, is I might send a command down to my device, but the device might not be connected at that time.
Correct.
With the durable messaging model, you have the message or the command which waits there. It's right there waiting for you. When you come back and the device gets connectivity again, it can go pull down that command securely and safely and do that. Right. So in both directions, having a broker in the cloud, and we'll talk about that next, will really, really help.
And will that also address the limited bandwidth issue?
The limited bandwidth issue, absolutely, because the part I talked about, AMQP, it's a very, very optimized protocol. It's a protocol built for efficiency, for reliability. So think about not having to sort of keep resending the same message and things like that, because you can get an ACK for the message and stuff. So really from the ground up, I'll encourage folks to read more about the AMQP protocol.
And what if they've already adopted a different protocol?
Absolutely.
Maybe they're early adopters in this space. They're fired up. We don't have to redo everything.
Right. And again, that's really the part about AMQP. Being an open standard, it makes it very, very easy for folks to continue working with other brokers, which support the AMQP 1.0 standard. No vendor lock-in in that way. And you have open source libraries, so you can really create your own APIs and stubs and however you want to extend that and be able to go.
Gotcha. So you don't have to completely rewrite what you started with. You can just extend it using AMQP to get that performance benefit.
Correct.
Perfect. Well, now that we kind of covered that, should we get into more of a deep dive on those 4 patterns of communication and show a little bit about what that looks like with a pub/sub model?
Sounds good. Absolutely.
All right.
So with the patterns of communication, which we already saw, Think of the first two, the telemetry and the inquiries, as being device initiated. So the device has some data to send, in this case, the Pi wants to send some information up. Or it has an inquiry to make, like for example, it wants to know, it's not able to communicate on the up channel, it wants to provision new security keys. So the device is initiating an inquiry in there. So those are sort of couple of patterns. And then on the other side of it is when the cloud or your smart app is sort of generating, initiating the conversation. And this is where your device has to respond to commands. And we talked about both intermittent connectivity as well as respond in a, a synchronous almost way. And it has to receive notifications. The most typical example of notifications in a device scenario would be firmware updates. Like you essentially go tell the device, hey, you have new firmware available, go to the file store or whatever and get the device in there. So with all of these, we're breaking them down as messaging patterns, right? That essentially the core aspects of messaging really apply well here. And the anatomy of a message, I just wanted to call out in Service Bus, is a bunch of properties. And property is a bag of key value pairs. And properties are things which you want to communicate at a little higher level with the broker. Because as I'll show you, you can use these properties for routing and filtering and different aspects. And then there's the message body. The message body is essentially the payload of the information. And that's why messaging is so extensible in this scenario. Your payload can be telemetry data. Your payload could be actually the firmware update which you want to send and all of those things. And the beauty of it is, from a broker perspective, that payload is completely transparent. So you can encrypt it end to end. And Service Bus will transfer it as is from one place to the other.
Fantastic.
So from a telemetry scenarios, the key challenges I think is mostly whether you have a scheduled or a event-driven scheme. So think about variable loads, right? If it's scheduled, it's not like all your devices are on the same schedule and things like that. So you really could have a lot of load in there. Think about tiny sort of stamps of information, all the way up to large, pieces of information. Like I've heard a lot of these new airplanes, the A380 and the Boeing 787, generate gigabits of data.
Wow.
Gigabits of data, because the number of devices and stuff are incredible on there.
Yeah.
So you can imagine telemetry there is at a different scale. So with all of those are the challenges, and that's where you see queues as being a key solution here, because queues really help you decouple the sender and the receiver. You don't have to have your back-end processing system, which is doing all the compute and the telemetry analysis and the storage online synchronously and keep up with all the bursts which are happening on the sender side. So you have that decoupling, and then you can have many senders fan into a single queue. So this is where we talked about that pattern where you can really use a few number of queues and have lots of devices.
I mean, I just feel, what are some of the pitfalls people would see if they went with one queue per sender at scale of millions of devices, or even at scale of one device with many streams coming in, like senders on an airplane and they're trying to all consolidate in one queue? What are some of the issues they'd run into?
Sure. So the advantage which you could see by putting in one queue is, firstly, you have much less management overhead, right? You have one entity to maintain, monitor, and get metadata on, manage your security on, kind of thing. The other advantage which you get is from the receive side, you have few endpoints on which to go listen to. And you are able to scale pretty well, is because you can manage the length of that queue. And as you see the length of that queue increasing, you can add more receivers. Now, queues have a competing consumer pattern. You can have more and more worker roles, pull off messages, and we'll see a little bit of that, and they can all process those messages independently. So having fewer number of queues really helps with those scenarios. Now, on the flip side, you may want to have queues for different message types and stuff, because you have different processors for different message types. So in that sense, it's it's okay to have a lot of queues. The other feature I want to definitely mention here is we've got auto forwarding, where you can hook up queues and topics together, and you can have rich topologies where you can have several queues fan into a single processing queue and things like that. And that way you can achieve those scenarios. The one advantage which folks could see there is they could isolate one sender from another sender by having them go to different queues. So, that could be looked at as a perceived advantage of that.
Interesting. So if it wasn't a super trusted sender, they could kind of route them to different queues.
Absolutely. So they could, on a per tenant basis, let's say you're an ISV and you're going to have, say 2 or 3 car vendors, you could create a queue per vendor so that you have them isolated.
Makes sense.
Things like that. Command and control. So this is another key scenario. And this is where you can see you want to tell a device, right? Or you want to tell a set of devices, right? And this is where topics with PubSub really comes into its fore. Because now you imagine the scenario, Miranda, like we just talked about, is that if you have a queue per device, and I want to tell every device to go update.
Good luck.
So you can imagine the sender's just going to be polling every queue and be, sending messages in every one of them. So that's where topics really come into the fore. That now you can have a subscription per device. And that's a great pattern to have. Where you can have every subscriber sitting off a single topic and then listening to its own subscription. What that means is, think of subscription as a receive side queue. So you send one message in, and let's say all the devices are true filter. All of those subscriptions get that message. If one device is online right now, it gets it right away. If a device is not online right now, its subscription continues to hold the message.
Perfect.
So in that way, in a topic and subscription model, you have a per subscription queue on the receive side, but on the send side, you have a single sender being able to address one or many in there.
Right.
So let's look at topics in a little more detail.
Okay.
And this is where you will see that message distribution is really the differentiator. Where in a queue, you can never have one message go in and more than one messages come out. In a topic, you can have one message go in and as many as subscriptions, that many messages come out.
That makes sense.
And the way to achieve these topologies is you can do filters and rules, where essentially filters can be mutually exclusive. So now you're doing splitting of the stream, right, where it's mutually exclusive. Or you could do duplication of the stream with just a true filter in there. So we can look at a quick example of filters. Let me bring up this application really quick. So here, what I have in my application is I'm creating a single topic and creating 3 subscriptions. The first sub, called an audit sub, receives all messages. So note here, I'm just doing a namespace manager, create subscription with an audit subscription.
And it's just got the main topic.
The next one, I create a rule. I say, hey, create a rule where the SQL filter says the property name category is equal to 1. So anything which is a category 1 message, I want to receive there.
Great.
And then I create a subscription and just pass in that rule description in there. And then the last one you can see is I just reverse that filter and I say, give me all messages where category is not 1.
Right.
So I have shown you all the 3 combinations. In first, you have all the messages available. The second is only those which are 1. And the third is where they are not 1 in there. So let's see this in action and what it looks like. It's just a console app. I'm going to create 4 console windows. On the left hand side is a sender window, which is going to be sending messages randomly on different categories. And on the right hand side, the first one is the audit subscription receiver. So here you can see as many messages being sent, all of them are being received and all in the same order. The second window from the top, let me zoom into that, is your category 1 subscriber. And note here, it only got messages which met that filter criteria in there. And then finally, we have the third and final subscription, which says where the category is not equal to 1. And here, I didn't get a single message, which was 1, but 2, 3, 4, 0, all of those were available. So this shows you how simple it is with PubSub patterns to create this kind of topology and work with that.
So when we kind of look at some of the features of filter, like up to 2,000 rules per subscription, I feel like not very many apps are going to actually approach that number. What are the scenarios where you see that first level of filtering reach the kind of upper limits there?
Ah, good. Absolutely. No, that's a great question, Miranda. Think about, when we talk about filters, it's 2,000 filters for the entire topic.
Okay.
So it scales on both angles.
Gotcha.
You can think about if you have a topic with 3 subscriptions, you could scale it where in the 3 subscriptions you could put, about 100 rules each or something like that. Or we let you go up to 2,000 subscriptions, in which case then you have a rule per subscription, which is the most typical scenario. That's why those 2 numbers are very correlated.
Right.
You have 2,000 subscriptions on a single topic, and you have 2,000 rules, which you can create on a single topic. Now, the rules I showed you was SQL, SQL rules, which are, a little very rich. You can have all SQL 92 format. You have several functions. We'll include documentation links on that.
Absolutely.
It's really the entire SQL 92 expression language. You can access all brokered message properties as well as user properties, so very rich. But there's another set of scenarios where you actually want to do instance level correlation. So an example of typical of that, think about request response. So let's say this device sent a request and you want to send a response to this particular device. In that case, you might be creating a rule on its subscription on a per message basis. And that's where you would want to use the name value pair the correlation filter. The correlation filter we allow up to 1 million instances on a single topic.
Wow.
And those are really geared towards scenarios where in the cloud you have services which are talking one-on-one with devices. They're saying, hey, I've got 1 million devices, I've got these 1 million conversations open, and I want to be able to pull a message, create a rule for that, process it and things like that. So that's why enterprise messaging wise, queues and topics really fulfill a lot of these broad scenarios and are able to capture that. Now, we already saw what we can do with PubSub in this particular example. I really want to show folks a command and control example.
That'd be great.
So this would be a scenario where you have on a per subscriber basis event which you want to tell the user some information. So let me switch back to my demo here really quick and set this up for you. So what's going on here is I've got a simple app. This is using mobile services, and it's like
Shameless
a point
plug.
of sale. Of course it is.
Go ahead.
And it is like a simple point of sale.
Yep.
So you can imagine, I can, on my tablet, I'm walking around in the store and I can go create a particular order and I can go and say, hey, submit this order.
Sure.
And, this is basically sending messages
Or even
back
like a registry or something like that.
or a registry and all of that information. So this is the outbound kind of thing.
Yep.
But now imagine the reverse side, right? This is where you have all of these point of sale systems which are sitting there. And a common scenario for them is when they have a catalog update, where essentially new products are available and they need to go reach out and they need to go get all that information. So to achieve that, let me bring this window here. To achieve that, what we can do is go with a queue and topic model, where right now, as I showed you, in the data collection topic is essentially where all the orders come in. And in this, you can see the subscriptions which I have is a simple ordered subscription because I just want all my orders which are coming in to come into a single
And if
topic.
anyone was trying to follow along, is this up on your GitHub account where they can access it?
This particular sample is on MSDN.
It's on MSDN. Great.
yeah,
What's the
so,
sample name?
The sample name is MartView, I believe. I'll make
Okay.
sure I include a link in
Fantastic.
so that.
We'll get that to you guys, but MartView, MSDN is probably the place to start looking for this, but it'll be available for download.
Yes. And essentially here we have all the messages from different point of sales fanning in. So you can imagine that you have a single processor for all your orders, which is sitting and pulling messages off that. On the reverse side, I have a catalog update topic. And for this catalog update topic, each point of sale dynamically creates a subscription. So now I'm going to just send a test message here. And what the way I have hooked up this app is that anytime the point of sale gets a message, it reaches out to its data store and pulls in all the new catalog and all the new information. So on my left hand side, you can see right now I've got a fair set of products in here. But next time when I do send a test message, it's actually going to go out and look in real time. It has gotten all the information on new products in there. So a very, very easy way in which you can see you can have that bidirectional connectivity of being able to send messages out from devices as well as reach back into devices.
And obviously that's scenario relevant not just for, hey, we have more stuff in stock that you maybe weren't aware of, but recommendations and upselling, especially in that scenario.
Absolutely, that's a great point, because all of this data, because of its live nature, it's always connected and you can, do real-time messaging. The smarter your backend system is, the more interactive and useful information that you can send down to the user.
Perfect. So I think we wanted to cover some general best practices and resources before we leave everybody at the end of Azure Week. We've covered a lot, but just to summarize, I know that we want to make sure everyone's using partition queues and topics.
Right.
Talked a lot about that. Sharding the data. So this is something we hadn't talked about yet.
Yes.
It's usually more of a topic they cover in SQL, but do you want to talk a little bit about that?
Absolutely, absolutely. So when we talk about partitioning your data, essentially you want to think about how do you scale your system in terms of the different aspects in which your application domain requires it. So let's take a couple of examples and maybe that will make it concrete. Let's say you're an ISV, which is producing applications on a per tenant basis. So you can easily see that your first partition would be on a per tenant basis. Then after that, within let's say the scenario was processing point of sale purchases, right? Now point of sale systems can be geographically distributed. So the next sort of way of partitioning could be based on region. So you could say north, south, east, west region kind of this thing. And what you achieve by that is essentially give yourself a lot of independent scaling capability and an independent reliability and availability capability, where essentially there is a message flow from north region and south region and east and west. Now imagine if suddenly there was a system failure where in north the orders and stuff were all backed up, and then you had all of them show up at the same time. Now you don't have a backlog overwhelming the entire messaging sort of topology across all systems in there. So that's why folks should really think hard about how to partition and how to sort of shard their messages and message types appropriately.
A couple clicks down on the sharding, obviously by region, and you could even do by store if it was a point of sale system, but as kind of that data history grows, or maybe as a lot of orders come in at once, what's the most efficient way to present that in order for it to be accessible to topics and queues? Right,
absolutely. So I think the best way in terms of for partition queues and topics is that you're able to scale your backends just as you monitor the load in terms of that. So the way it would be is you would tie your backend processing to each of these shards. So several topics. Let's say you had an order topic north, order topic south. You would have a backend role which is processing both orders topic north and south, and then you can say, hey, orders topic the subscription length is really growing, so maybe what we should do is put more backends for the south or for the north order, and that's how you put it.
So to kind of match that backend scaling to the actual shards themselves and kind of have a more compatible relationship there than having one centralized backend that's got data growing everywhere.
Which has to look across everyone would be in there. And that's the idea about sharding a system through and through. Sorry, a very good point, Miranda, is that you shouldn't only think about service bus or one layer in terms of that. You should think through and through and sort of shard system. Because that's how essentially the scale out model will work very well, step by step.
Perfect. And we do have a couple links to helpful resources. We will get a link added in terms of the code we used here today in the demos. But a great series by your coworker Clemens on some of the things we covered today. He plays with a Raspberry Pi too. Not sure if his is quite as red as ours. I think it's more of like a pink. I'm not sure.
No, but I would say this is the episode 7 in which he actually has the Pi in the car is really a good end-to-end scenario because he actually uses it.
Yeah, he's driving on the Autobahn.
Right.
He's filming on the Autobahn.
Exactly. He's actually using and filming that episode while he's driving. So it's
With
actually
an
very
assistant,
awesome.
with a driving assistant. But yeah, we are always happy to get feedback. Feedback.windowsazure.com, great place to submit feature requests.
Yes.
The MSDN forums for Service Bus, closely monitored by the team. Always looking for feedback. And we are very glad that you joined us for Azure Week. We are privileged to be the anchor leg, not just on the week in terms of a mobile day, but Vishek and I here as the last session. So thank you so much for making this happen. We try to bring you the information you want, keep the dialogue coming. We're happy to present whatever you need to hear about. Don't forget to fill out the poll under your screen. And thank you so much, and we look forward to seeing what you build with Azure.
Thank you.